Hi everyone, welcome to the next topic of file groups in geotechnical engineering 2. Up to now, we have discussed about the different types of formulas for calculation of the load carrying capacity of the file. In today's class, we are going to discussing about the load carrying capacity of group of files. Normally, based on the load carrying capacity, in very normal situation will provide a single file where the load carrying capacity of the file it will be want to take more amount of load. In that situation will take the load carrying capacity maximum amount of the load if you want to apply that particular type of this file. In that situation we'll use the more number of files. By using more number of files, the load carrying capacity it will make it increase. That number of files keeping on file cap and we are transferring the load onto the files, that it will be called as the group action of files. That group action of files we will discuss 1 minute. Okay, coming to the file group, and if you observe here, number and spacing of the files in a group and what is meant by group action of the files. If you observe in starting itself, I have shown one image. In that image I kept one file cap like this, and in bottom we provided the some number of files. In that number of files we are providing a column. Here for one particular type of file cap we are kept here number of files. Based on the load carrying capacity, if you want to increase the carrying capacity of this oil mass, in that situation we will provide one file cap. In that file cap will be inserted the number of files. Based on that number of files, again the carrying capacity of this oil mass, carrying capacity of the file it will may increase. In this type of file group, how many number of files we should have to insert and we should have to keep, and what is the spacing between the individual file. Based on the load carrying capacity it will may increase. If you come to here, number and spacing of a files in a group, when you are providing number of files in a particular file, in that situation how many number of files and what is the spacing you can provide for the individual file spacing. Very rarely are structures founded on a single files. Normally there will be a minimum of 3 files under a column or foundation element. Because of alignment problem and enactment eccentricities, the spacing of the files in a group depends upon the following factors. Where the load carrying capacity of the file is very less, in that situation we will provide in a single file normally. Where the load carrying capacity it may have large amount of load, in that situation we will provide some number of files. Based on the provision of number of files, the carrying capacity it will may increase. Normally we will provide 3 number of files as shown in the image like this, and above this file we will provide one file cap which is useful to transfer the load to the underground 3 files equally. And if you see here, file groups depends upon the many factors such as overlapping of the stresses of the adjacent files, cost of the foundation, and efficiency of the files group. Suppose if you, instead of this small diameter number of files, if you inserted the one file with a large cross-sectional dimension, in that also we can provide, but the load carrying capacity it will may vary. Whereas the overlap stresses also will may develop into the files. Hence, based on the carrying capacity, we will insert the number of files. If you observe in this diagram above here, okay, above here in this diagram itself, here this is the file cap, and here these are the number of files with some spacing of distance. We are applying the load from this top portion to this file cap, and in this file cap will transferring the load equally to this 3 number of files to the underground soil mass. Okay, that is the thing. The soil is highly stressed in the zones of overlapping of pressure. With sufficient overlap, either the soil will fail or the file group will settle excessively. Since the combined pressure bulk extends to a considerable depth below the base of the files, if possible to avoid overlap, installing the files further apart as shown in the figure. By seeing the image, I will explain the concept. Okay, suppose if you consider here, this is your ground surface. In this ground surface, I am inserting one file here. and again this is one more ground surface, and I am inserting one pile. If you observe here, the load carrying capacity of the pile, the stress distribution of the pile, it will be like this. For this pile, again in this pile also the stress distribution it will be like this. If you observe here, for these two number of piles, there is a stresses are overlapping in between these two soils. Because of overlapping of these soil in between these two piles, this load carrying capacity it will may decrease. Based on this condition, overlapping of stresses will provide some maximum spacing between the individual piles without giving the excessive settlement or excessive deformation for this overlap of the soil mass. In that situation, based on the overlapping of the stresses, we have to provide the minimum number of piles as well as spacing of the pile. If you come to here, these are the some of the features which represents the how the piles we can arrange or how the number of piles we can keep in the underground soil mass. If you see here, this is the one pattern for if you see here, this is the one pattern for the application of piles practically providing in the field itself. This is the triangular portion, and again if you observe here, for the spacing we are providing the 0.87 times. How much spacing for the individual piles we are keeping based on the side of the side, 0.87 times for each side we are keeping the distance. Again if you observe here, for 4 number of piles when you are providing, for 4 number of piles we will arrange the piles in such a way that where S is the spacing of the pile. And again if you want to provide the 5 number of piles, in 5 number of piles in width direction as well as in length direction, we will arrange the pile pattern in such a way that. Again if you want to provide the 6 number of piles, for the 6 number of piles we will arrange the pile spacing as well as pile diameter based on our requirement. We will provide the pile arrangement like this. This is the various type of patterns how practically we are inserting the pile into the underground surface. Again if you observe here, this is the also one of the most important pile pattern, that is 9 piles in row 3 piles, in column 3 rows we are providing in such a way that these are the number of piles we are digging into the underground soil. Above this we will provide the one pile cap, and here we inserted the column load, and from this column load the load will be distributed into the underground soil mass based on the loading requirement, based on the carrying capacity of the soil, based on overlapping of stresses. The number of piles will provide to the particular type of the loading condition. Generally, the spacing for point bearing piles such as piles founded on rock can be much less than for the friction piles, since the high point bearing stresses and superposition effect of overlapping of the point stress will mostly likely not overstress underlying material nor cause excessive settlement. That means where you are providing the piles, whether you are providing in the very soft soil or medium to soft soil, or whether you are going to providing in the very hard soil, based on the load carrying capacity of the soil also, based on the carrying capacity of the soil mass or rock mass also, you can insert the number of piles. If the load carrying capacity of the soil is very big, then you can insert the more number of piles. If the load carrying capacity of the rock or soil is heavy, then you can insert the minimum number of piles in a group. This is the content. And again if you see here, the spacing for straight uniform diameter piles may vary from 2 to 6 times the diameter of the shaft. How much diameter you are providing to the shaft, that will vary from 2 to 6 times. For friction piles, the minimum spacing recommended is 3D. For frictional piles, in which condition you are using the friction pile? For friction pile, suppose this is you are inserting one friction pile, and for this friction cell, the minimum spacing you are inserting here, it should be 3 times the diameter of the pile. For end bearing pile passing through relatively compressible strata, the spacing of piles shall not be less than 2.5 times the diameter of the pile. Suppose if you are inserting the end bearing pile or point bearing pile, in that point bearing pile, while you are inserting 2 number of piles, you are keeping the piles in between. This distance it should not be less than. Compulsory you should have to provide more than 2.5 times the diameter of the pile. What is the diameter of the pile you are using? For this diameter 2.5 times of the distance you should have to provide, and you should have to give the distance to the secondary pile. That is the thing. For end bearing pile passing through the compressible strata, okay, increased from 3.5D, whereas end bearing piles compressible size, that means maximum amount of load carrying capacity will be decreasing. In that situation 3.5 times of D of the pile diameter spacing will keep for the based on the type of the soil condition. Next, based on this keeping the number of piles in a group, the load carrying capacity of the piles it will may increase. That will be called as the group efficiency. Suppose the load carrying capacity of single pile it will may be either less compared to the number of piles inserted in the same type of the soil mass. Suppose here I am taking the ground surface and I am inserted here one single pile, and here I am applying the some load, and again the same type of soil besides this again I am inserting 2 more piles or 3 more piles, and I am providing one pile cap, and again I am applying the load. In this situation the load carrying capacity of the piles will be more compared to this individual pile. Okay, that it will be because of the number of piles we are inserting, and the efficiency of the pile it will may increase. If you come to here, the design of pile foundation subjected to a vertical loads consists of, okay, the pile foundation how you are designing, that it will be considered based on the determination of the ultimate load carrying capacity group action of the pile. That means by providing individual number of pile into the soil mass, how much the load can be taken by the pile, that we should have to study, as well as by providing group of piles or number of piles inserted into the ground surface, how much the load carrying capacity of the soil mass it will make it vary, that also we should have to study. Okay, well before knowing the group action of the piles or efficiency of the pile. Again if you see here, determination of the settlement of the group, yes, under allowable load. That means if you apply the load, due to application of the load, how much amount of settlement will be acting on the group of piles, that also we should have to know before inserting into the underground soil mass. First we should have to determine how much amount of ultimate load carrying capacity will be available for the group piles, as well as determination of the settlement of the group. For this group, how much settlement it will make it possible. These 2 points we have to determine. And if you come to here, the ultimate load of the group is generally different from the sum of the ultimate loads of the individual pile. That means I will show by showing image. I will explain that. Suppose this is your ground surface, and here you are inserted the one pile, individual pile you are inserted, and this is also your individual pile, and this is also one individual pile. For this individual piles you are calculating the load carrying capacity, and suppose you are taking this as QU1, and you are taking it as QU2, and you are taking it as QU3. This is individual pile, this is individual pile, this is individual pile. By adding these 3 number of piles, you will get the ultimate load carrying capacity, that is QU1 plus QU2 plus QU3. This is the individual pile ultimate load carrying capacity. For the same type of piles, again I am taking this ground surface, and again I am here providing one pile cap, and here I am taking the pile as a group of piles. Here I am inserting some group of piles. For this group of piles, again I am applying the load. In this condition, the load carrying capacity of the individual pile it will may get different, or it will make it equal based on the loading condition, based on the soil type of the soil parameter. It may not be necessary exactly the load carrying capacity of the individual pile will be equal to the load carrying capacity of the group action of the piles. Okay, next if you see here, the ultimate load of the group is generally different from the sum of the ultimate load of the individual piles. That is the point we have discussed now. The factor is called group efficiency, which depends on parameters such as type of soil in which the piles are embedded, method of installation of piles, that is either driven or cast in situ or board piles, as well as spacing of the piles. If you take the individual number of piles, in individual number of piles, what type of pile you are providing to the underground soil, and what method of driving the pile into the underground soil you are going, and what is the type of the soil available at the particular ground surface while inserting the individual pile, that it will be depend upon the number of individual piles, as well as the group action of the piles also will be depend on these parameters. That means the type of the soil mass, as well as how much spacing you are providing for the individual pile, and what is the diameter of the pile you are using. Okay, based on all these conditions, the load carrying capacity of the efficiency of the pile group, it will may increase. If you apply same amount of load also, the load taken by inserting number of piles into the group, it may be different from the same load you are applying to the other group action of the piles. The efficiency of the group action of the piles we are having Eg equal to QGU divided by summation of QU. Eg equal to efficiency of the group action of the piles equal to QGU divided by, that means group action of the load carrying capacity of the piles divided by summation of individual load carrying capacity of the piles. This is the thing for a pile group condition. And pile group efficiency equation, we are having one formula, that is the Canvers-Labrere formula. There are many pile groups equations. These equations are to be used very cautiously and may in various cases no better than good guesses. The Canvers-Labrere formula is one of the most widely used group efficiency equation, which is expressed as follows. I will show this image. Again, I am repeating here. Suppose this is your ground surface. In this ground surface, you are inserted the number of piles, and you are calculating the load carrying capacity of this pile, and as well as load carrying capacity of this pile, and the load carrying capacity of this pile. And in second condition, in the same soil, suppose I am providing one pile cap. In this pile cap, by provision of one group action, and I am inserting the 3 more piles. Again, in this also I am applying the load, where the efficiency of the group action of the piles Eg, it will be depend upon the QEG. That means ultimate load carrying capacity of the group of the piles. This group of piles you are inserting and you are applying the load. It will be equal to the summation of the load carrying capacity of the individual piles. The summation of the individual load carrying capacity, it will be QU1, QU2 and QU3. It will be depend upon the spacing of the pile, type of the soil mass, and how much diameter you are giving, and what is the type of the soil available for this soil mass, as well as what type of methoding technology you are using for inserting these piles. Based on this, the load carrying capacity, it will may vary. Next, we are having the efficiency of pile group by using Canvers-Labrere formula. In this Canvers-Labrere formula, we are having, this is the equation. Okay, this is the equation. That means efficiency of pile group Eg equal to, in the efficiency also they will represent Eg equal to 1 minus theta by 90 into n minus 1 into m plus m minus 1 into n. Okay, otherwise okay, this is the formula. Efficiency of group action of the piles equal to 1 minus theta divided by 90 into n minus 1 into m plus m minus 1 into n divided by 90 into m. If you observe here, where m is the number of columns of piles in a group. Suppose if you are this is your group. In this group you are inserting suppose 9 number of piles. This is one set, and this is one set, and this is another set, and that means you are arranging the number of tiles in a group as 3 rows, as well as we are inserted as in the 3 columns. If you observe in this diagram, in row we are having the 3 number of piles, in columns we are having the 3 number of piles. Again, if you observe this block, if you observe this group, in this group we are having the where m equal to number of columns piles in the group, where m equal to number of columns of piles in the group. How many number of columns? These are the columns. How many number of columns are there in the pile group? That is the m. And where n is the number of rows. If you observe here, this is the number of rows. In number, how many number of rows are there? How many number of columns are there? These are the representation of m and n. And where theta equal to tan inverse of d by s in degrees. Where theta equal to tan inverse of d by s in degrees. And d is the diameter of the pile. Where how much amount of diameter you are keeping for this particular type of the pile, that will be depend upon the d, where d is the diameter of the pile. And s is the spacing of piles center to center. From the center of the pile to the center of the pile, how much spacing you are providing. as well as this center to this center, how much spacing you are providing. Again from this center to this center, how much spacing, this center to this center, how much spacing you are providing. This is the formula for Converse-Library equation to find out the efficiency of the pile group, where efficiency of the pile group is equal to 1 minus theta by 90 into m into n minus 1 plus n into m minus 1 divided by mn, where m is the number of columns of piles in the group and n is the number of rows of the piles and s is the spacing of the two piles and d is the diameter of the pile. Based on this, the load carrying capacity it will may vary. Again, if you see here, vertical bearing capacity of the pile groups embedded in sands and gravels can be calculated by using this formula. The load carrying capacity in gravel and sand can be calculated by this formula, where that QGU is the ultimate load carrying capacity by calculating the individual load carrying capacity of the single pile, where that ultimate load carrying capacity of the number of piles QGU equal to n into QU, where n is the number of piles and QU is the load carrying capacity of the individual pile. The same example what we have discussed in the previous condition. This is the ground surface. Okay, this is the ground surface. In this ground surface we are inserted the one pile here, and we are inserted the one more pile here, and we are inserted the one more pile here. This is Q1 and this is Q2 and this is Q3, where the group efficiency QGU equal to n, where n is the number of piles, that number of piles summation I am taking n into where QU means load carrying capacity of the individual pile. This pile how much load carrying capacity, this pile how much capacity, this pile how much capacity. In groups and sands, the individual piles load carrying capacity we are getting by using this formula. Then okay, if you observe this diagram, this is the image how the load will be getting transferred to the group action of the piles. If you see here, this is the cross section or block failure of the piles in some example. If you observe here in top view, if you observe, this is the how the piles are looking like this, and if you see the in the cross sectional view, in cross section from side view, this is the piles how it will be looking like. And if you see here, this is the ground surface. In this ground surface, to distribute the loads equally, we are inserting one pile cap here, and this is the gross load we are applying on the pile cap. This pile cap will transfer the load to this pile, and from this pile the load will be transferred to the ends of the bottom of the piles. And based on the what type of pile you are giving, either you are giving end bearing pile, friction pile, compaction pile, based on that load carrying capacity it will may increase. This is the perimeter of the block, that means how many number of piles you are providing into the underground surface and what is the spacing you are providing for this individual piles. This is the spacing of the pile, and this is also spacing of the pile, and this center to this center also spacing of the pile. These are the different type of spacing of the piles, where perimeter, this will be called as the block. This block also some failure it will may happen. Based on the width of the block and length of the block, the load carrying capacity of the soil mass also will be a value. The perimeter we are taking it as the PG. Okay, block failure of piles in groups of clayey soil. Some situations by inserting these number of piles also into the underground soil, where the load carrying capacity exceeds the ultimate load carrying capacity. In that situation, this group of piles also will make a failure. And pile groups in coasue soil, the load carrying capacity of the piles while you are inserting group of piles in sand and gravel, the load carrying capacity it will may vary compared to the same number of group action of piles while providing in the coasue soil. If you come to here, the effect of driving piles into the coasue soils, clay and silts is very different of that coaseous soil. That means while you are inserting while you are driving by giving some action by hitting action and driving action into the soil mass, when inserting the piles into the coaseous soil, it will may get different from the coaseous soil. It has been already explained that piles are driven into clay soils, particularly when the soil is soft and sensitive, there will be considerable remolding of the soil mass. That means suppose if you are this is the soft soil you are considering. This is the soft soil. In the soft soil, while driving the piles into the underground soil, the soil what is available here, what is the soil presence of here, the soil properties it will make it modified and it will make it densified based on the softness of the soil mass. The load carrying capacity of the soil mass it will may change, soil condition it will may change, and piles should be spaced at a greater distance apart without getting overlapping of the spaces. The piles you are providing should have to provide some greater distance. Piles should be driven from the center of the group towards the edges. From center to edges we should have to go to insert the pile. The rate of driving force of each pile should be adjusted as minimize the development of the pore water pressure. Experimental results incline that means while you are applying the load, due to application of the load, the soil what is there here, while applying the load due to this application of the compaction of the soil mass, pore water pressure it will may get developed in cohesive soil as well as cohesionless soil, and it will disturb the effective adjustment of the soil mass. Okay, the experimental results have indicated that when a pile group installed in a cohesive soil is loaded, it may fail by any one of the following ways. Suppose if you are inserting the group action of piles into the cohesive soil by driving action, may fail as a block fail called as the block failure. That means if you are inserting the group of piles, while inserting the group of piles by action of driven into the cohesive soil, while inserting the group piles itself, it will make it failure due to the application of the load as well as the soil parameters. If the group action of the piles, number of piles in the group are block, it will make it failure, that it will be called as the block failure of the soil